Tension. Tension is a contact force. As you have seen, tension will be acting only if the body is in contact with the rope. So tension is a kind of contact force. Previously we studied normal reaction, which was also a contact force, and previous to that we studied gravitational force, which was a field force. Now we're going to study the fourth force, which is called spring force. Suppose, similar to the previous situation, instead of the string, we have a spring and a block is attached to that spring. Like this. The spring is its unstressed, relaxed position. So there is no stress, there is no strain, there is no force acting on the spring, and the spring is in its unstressed, relaxed position. Now what we do, we are pulling the block to its right. Now since the spring is attached to the block and it is also attached to the wall, along with the block, the spring will also move forward. So it has to be stretched. So when we do that, spring becomes stretched and it comes along with the block. Now in order to stretch the spring, some force has to be applied, and that from your practical experience you must have experienced sometime in your pen. When you push the lid, when you push the knob of your pen, the lid of your refill, that comes out because you exert some force on the knob, and that's why the lid comes out. So in order to stretch the spring or in order to compress it, you have to apply some external amount of force. That's not going to happen on its own. And when you stretch the spring wants to come to its original unrelaxed position. So there will be some spring force acting inward to bring the spring back to its original unstressed position. So you have to do some work, you have to apply some force. So suppose F force is applied on the block, and with the spring, with the block, the spring also moves forward and it is stretched by a certain amount. Now let the stretch be X. Spring is stretched by an amount X. Now obviously, since it is stretched, there will be some restoring force in the spring, and that will try to bring the spring back to its original unstressed position. Now there will be some force. That force is equal to minus K into X. X is the displacement, Sx is the stretch that the spring had, and K is the spring constant, depending upon the strength, the thickness, the tensile strength, the elasticity of the spring. So K is a constant and will depend upon the kind of spring we are dealing with. So K is a spring constant and X is the displacement. That means we displace more and more. If there's more and more stretch in the spring, then the spring force is going to be more and more, and it will be increasingly difficult for us to stretch the spring and actually make it straight, because to a certain extent we can pull it, and pulling it further will become very difficult. As we go on stretching it, we have to apply more and more force into the spring. So generally this is the equation of force that governs the spring force. Spring force becomes large and large as the displacement becomes large and large. It depends upon the displacement, it depends upon the stretch in the spring. So this depends upon the stretch and depends upon the spring constant. So this is the spring force. So this is the formula that we'll be rigorously using later, and this is although all the spring will not follow this equation of force, but in our scope, whenever we see a spring, we assume that the spring follows this equation of force. This is the relation between the spring force and the stretch that the spring has. Now there's a minus sign appearing in this relation. As you can see, if this spring is stretched in this direction, that means the block had the displacement in right hand side, then the spring will try and restore its initial position. So the spring force obviously will be acting in opposite direction to the stretch. So this is the direction in which the spring force will be acting, and force and displacement both are vector quantities, we know. So if they both have vector quantities, so they both have direction. So when you put a displacement here, we put with direction, although we have not mentioned the vector sign here, but we do understand that force and displacement are vector quantities. So when we put a displacement here, we put it with sign, and the force is exact opposite to displacement. So if there is a sign of displacement here, the minus sign ensures that the sign of force is opposite to that of displacement. which comes from the physical understanding of this. The force will always be opposite to displacement. Similarly, if we did not stretch the spring, if suppose we compressed the spring, if we compress the spring by amount x, suppose, now on compressing the spring, again we have to apply some force. When you try to compress the spring will again try and come back to its initial unstressed position, and spring force will try and push the block outward. We try to push the block inward, the spring force will push the block outward. So this time the displacement is towards left and the spring force will be towards right. So again it is opposite to the displacement. It will always be opposite to the displacement because it is a restoring force. You try to push it inward, restoring force will try to push it outward. You try to push it outward, restoring force will try to push it inward. Spring force is a restoring force. It will always be against the displacement you are producing the spring. That's why there's a minus sign in this relation. Okay? So this is a spring force for us, and this is the relation of displacement and the force. So will you tell me very quickly, suppose there's a mass of 9 kg and this is a spring with spring constant K, and that is equal to 15. What will be the unit of spring constant? From here you can see it will be Newton by meter, Newton per meter. So the K has a value of 15 unit, the spring constant of the spring, and this block is of 9 kg. Now this presently the spring is at its unstressed relaxed position. Now what I'm going to do, I'm going to relieve this block. Initially the block was on my hand. I'm going to release this block very slowly and gradually, and then ultimately I'm going to remove my hand. So what will happen, due to the weight of this block, the spring is going to be stretched a little bit. When it comes at equilibrium, due to the weight, the spring will be stretched. Now by what amount the spring will be stretched, dear? So the spring force will have to be equal to mg, that is coming from the first law of Newton. Spring force is k into x magnitude, and this weight mg would be 9 into 10. Although you should take 9.8, but I'm trying to be convenient here and I'm taking 10. So 90 by 15, the displacement will be 6 meter. That is huge, because generally the spring constant will be higher. I have given you a very low value of spring constant. Anyways, so this is the kind of thing that we'll be dealing. Presently we're trying to understand the kind of force we have to deal with. So we have understood 4 kind of forces: gravitational force, which was the field force, and then we studied about normal reaction, tension, and spring force, which are contact forces. We're going to look at one more force and then we're going to start our business.